Assalamualaikum, my name is Nurika Tanisha binti Muhammad and my metric number is AF200061. So in this slide, I will be present about the introduction, which is the background information. So the first one is declining groundwater quality, and the resident report changes in taste and smell of well water. Tests show elevated levels of nitrates and industrial solvent. And the second one is about the sources of contamination, which is in agricultural runoff, which is the pesticide and fertilizer introduce nitrates and phosphates. Industrial leakage, improper disposal of waste leads to hazardous leaching. And in sewage treatment issues, inadequate facilities and leaking septic tank add pathogens and nitrates. And in landfills, is poorly managed site leach heavy metals and organic pollutants. So the third one is the common contaminants, which is it has four, which is heavy metals, nitrates, organic pollutants, and microbial pathogens. And the fourth point, which is health impact, in acute effects, which is gastrointestinal illnesses, skin rashes and respiratory problems, and the chronic condition, which is cancer, neurological disorder, and reproductive issues. The mitigation measure, which is the regular monitoring of groundwater quality, enforcement of strict environmental regulation, proper waste management and disposal practices, enhancing sewage treatment infrastructure, public awareness and education on contamination sources and risks, use of remediation technologies like bioremediation, phytoremediation, and chemical treatment. Next, we move to the scope, which is the first one is the baseline data collection, which is comprehensive testing for contaminants, which is like nitrates, heavy metals, organic pollutants, and microbial pathogens. And the next one is the regular monitoring program. It is ongoing tracking of groundwater quality and sampling near suspected contamination sources, which is like agricultural areas and industrial facilities. And next is the identifying sources of contamination, which is investigation into agricultural practices for nitrate sources, and inspection of industrial facilities for chemical leaks, and assessments of sewage treatment facilities and septic system. And the health risk evaluation is assessing acute and chronic health effects on local population, and evaluating environmental impact on ecosystem. And the regulation and remediation, which is developing and enforcing stricter regulation for waste disposal, chemical storage, and agricultural practice. Implementing remediation technologies such as bioremediation, phytoremediation, and chemical treatment. Next is upgrading infrastructure, which is upgrading sewage treatment facilities and ensuring proper maintenance of septic system. And the public awareness and community engagement, it's about educating residents on contamination sources and risks, engaging the community in monitoring and reporting contamination, and lastly is creating a platform for residents to share information and concern. Sustainable practices, which is encouraging sustainable agricultural industrial practice and promoting green technologies and pollution prevention measure. Long-term groundwater management plan, which is developing strategies for sustainable water use, implementing contamination prevention and resource conservation measure. And the last one is collaboration and research, which is collaborating with local government agencies, environmental organization, and research institution, and supporting research initiative for new technologies in contamination, detection, prevention, and remediation. Next, we jump into the objective, which is the first one is identify and mitigate contamination sources. This is about conduct through baseline data collection and regular monitoring, test for various contamination, investigate agricultural practices for nitrate contamination, inspect industrial facilities for solvent and chemical leaks, assess sewage treatment facilities and septic system. And for protect public health, it's actually for evaluate acute and chronic health effects of contaminants on the local population, assess broader environmental impacts on ecosystem, implement remediation technologies, and upgrade sewage treatment facilities and maintain septic system to reduce domestic contamination. So the third one is about raise public awareness and engage the community, which is we can conduct public awareness campaign about contamination sources and risks, educate residents on minimizing personal exposure and protecting water quality, and foster community involvement in monitoring and reporting contamination. And the last one is establish a platform for residents to share information and concerns. For the promote sustainable practice and long-term planning, which is encourage sustainable agricultural and industrial practice, promote the adoption of green technologies and pollution prevention measure, develop a long-term groundwater management plan with strategies for sustainable water use, contamination prevention and resource conservation. Lastly is the foster collaboration and support research, which is collaborate with local government agencies, environmental organization and research institution, and support research initiative to develop a new technologies and method for detecting, preventing and remediating groundwater contamination. For the key theoretical concept, which is the first one is Darcy law. It's describe groundwater flow through porous media. Flow rate is proportional to hydraulic conductivity and hydraulic gradient. Influences remediation strategies and groundwater protection. And the flow paths in aquifer, which is determined by porosity and influences the rate and direction of groundwater movement. Contaminants transport mechanism, which is advection. Contaminants move with the bulk flow of groundwater. Dispersion, spreading of contaminants plumbs due to velocity variation. Diffusion, movement of contaminants from high to low concentration area. Retention, contaminants are retained through absorption and a chemical reaction reducing mobility and concentration. Sources of contamination, which is point source, leaking storage tank, industrial spills. Non-point sources is agricultural runoff and urban runoff. Type of contaminants, which is organic compound, which is pesticide and solvent, or inorganic compounds, heavy metals and nitrates. Pathogens is bacteria and virus. Aquifer vulnerability, which is influenced by aquifer sensitivity, recharge rate and protection measure. High recharge rate can increase vulnerability by transporting contaminants rapidly. And the last one is effective protection strategies include land use planning and groundwater monitoring. So for the next slide is about the monitoring strategy to ensure effective progress tracking, which is the baseline data collection is establish current groundwater quality and the sample multiple wells for nitrates, industrial solvent, heavy metals and microbial pathogens. Document sensory observation from residents. Regular monitoring program, which is periodic sampling near contamination sources. Monitor indicator like nitrates, solvent, pH levels, turbidity and microbial contamination. Adjust sampling based on seasonal variation and influencing factors. The contamination specific monitoring, which is focused on key contaminants like nitrates and industrial solvent. Set target levels based on regulatory standards and health guidelines. Use advanced analytical techniques for accurate measurement. And the community and stakeholder engagement, which is transparent communication on monitoring, result, remediation progress, and emerging issues. Involve residents in observing water quality changes and providing feedbacks. Conduct regular meetings or workshop to educate and empower residents. So the data management and reporting, which is used as centralized database for secure data storage and management. Employ GIS tools to map result and contamination sources. Generate regular reports for stakeholder, regulatory agencies and the public. Adaptive management and response, which is enable timely adjustment to remediation strategies based on monitoring data. Establish protocol for interpreting result and triggering corrective action. And collaborate with experts and stakeholders to evaluate and incorporate new approach and investment. So the last slide, which is the frequency and location of monitoring well, which is frequency of water quality testing. Conduct frequent testing initially. Capture seasonal variation and potential contamination spikes. Detect acute contamination event promptly. Strategic location and monitoring wells, which is select location near suspected contamination sources. Place well strategically in residential area to monitor downstream impacts. Monitor to pinpoint sources and pathway of contamination. Adjusting monitoring frequency, which is modify testing frequency based on observed data trends. Consider reducing frequency if contamination levels stabilize within acceptable limits. Maintain vigilance during critical periods of agricultural or industrial activities. Monitoring strategy implementation, which is combine strategic location selection with appropriate testing frequency. Track progress of remediation if efforts effectively. Mitigate risks associated with declining groundwater quality. And the last one is adaptive management and data analysis, which is analyze data regularly to inform adaptive management decision. Address ongoing challenges in groundwater quality management and achieve sustainable improvement in water quality and environmental protection.
I will continue with the site selection and data gathering. This chapter explains the site selected for conducting this study. Field research like the location, geological setting, and land use is used to describe the site. Besides that, well log, geological maps, and hydrological data will be used for the data collection in this section. Shah Alam is the capital city of the state of Selangor, Malaysia. The suburban area around Shah Alam has mixed land use, including the residential, agriculture, and light industrial zone. Initially spanning 41.69 km square in 1979, Shah Alam has since rapidly expanded to cover 290.3 km square. The graph shows the land use distribution in Shah Alam according to the MBSA Shah Alam City Council Report 2020. Shrubs cover 24% of the area, while accommodation and housing area occupy 16%. The road and agriculture each take up 12% of the land, and the industrial zone each account for 8% of the area. Shah Alam also experienced a tropical climate characterized by relatively consistent temperature ranging from 25 to 33 degrees Celsius throughout the year. The average annual rainfall in Shah Alam is approximately 2,300 mm, contributing significant to its environment dynamic and water management consideration. The total drainage basin area around Klang River is approximately 1,290 km square. The Shah Alam area is characterized by an underlying geology of alluvium atop the Canny Hill Formation, which is turn overlay in limestones. The Canny Hill Formation consists of metamorphosed clastic sedimentary rocks as described by Gobert and Hutchinson in 1973. The formation forms a broad synclinal belt and comprises a repetitive sequence of interbed shells, mudstone, sandstone, and conglomerates. The sandstone beds within the formation exhibit greater resistance to weathering compared to shale and mudstone, which can sometimes exhibit phyllitic characteristics.
Remediation technique. First, pump and treat, a try and true technique for treating groundwater contamination including TCE. Second, in situ chemical oxidation, ISCO, one of efficient technique for quickly degrading TCE in groundwater. Air spugging. Through the process of air spugging, TCE is volatilized and subsequent extract via soil vapor extraction, SVE. Then bioremediation. By using microbial process, bioremediation convert TCE into non-toxic substance. Remediation method. The most appropriate remediation strategy is in situ chemical oxidation, ISCO. Include the soil permeability, groundwater table and necessity for relatively quick repair. The cost-benefit study demonstrates that ISCO's speed and efficacy can outweigh the initial outlay, resulting in a quicker resolution of contamination-related problems.
Community and stakeholder engagement plans. Community and stakeholder engagement forms the cornerstones of developing a comprehensive plan for groundwater contaminations. So, by emphasizing transparency, collaborations, and effective communications, this engagement aims to maximize the efficiency of remediations. The document outlines a structured approach to engage with the community. So the first one is regular updates and communications, designed to keep the stakeholder informed about the ongoing effort to remediate groundwater contaminations. And second, public meeting and workshop play a crucial role in promoting direct engagements and dialogue between project leaders and the community. The third one is community advisory group. Ensure that the perspective of local stakeholders are central to decision making through the remediation projects. Addressing community concerns, a proactive stance towards addressing community concerns entail establishing clear protocols and designated contract to manage inquiries. Educations and outreach essential for increasing awareness about groundwater contaminations, and the last one is feedback mechanism. It creating to easily accessible channel for stakeholders to offer feedbacks is crucial for sustaining continuous dialogue and assessing the efficiency of engagement tactics.
So hi everyone, so I'll be presenting on the well. So as you can see on the left side is the well in the study area, and the left side is wells in contamination zone. So the wells are located at industrial sites for industrial purposes. So the location of the wells are clustered in the central part of Shah Alam, which is near the Damansara and also the Fang rivers. So next we proceed with the public health. So the first one is drinking water contamination caused by the chemical and also biological contaminant such as arsenic, lead and nitrate. Next is food chain disruption, which is agriculture input. So contaminated groundwater used for irrigation can lead to the accumulation of harmful substances in crop, which is affecting the food safety. And last but not least, direct contact risk, which is skin irritation and infections. With the environment, so the first one is aquatic ecosystem, which is toxicity to aquatic life. Heavy metals and chemicals can be toxic to fish, invertebrates, and also the plants. So next is soil quality degradation, which is called soil contamination. So pollutants can seep into the soil, reducing its fertility and affecting the plant growth. And last but not least, terrestrial wildlife. So these can cause habitat contamination, which is contaminated groundwater, and also water source dependence, which is wildlife that depends on contaminated groundwater sources may suffer from heart issues and affecting the biodiversity. These mitigation measures. So the first one is monitoring and assessment. So regular testing of groundwater quality to identify contamination sources and also the level. So next is public health interventions. So provision of clean drinking water through alternate sources or treatment system. And last but not least, environmental protection. So implementation of pollution control measures to prevent the further contamination.